Hi, guys. Just want to make sure the speaker's on. Okay, so hi. I'm going to go through this lesson with you today. If you have any questions, you can always hold on until tomorrow. The homework tonight is Delta Math, but it's not due till Monday. All right, so the first two questions are review. All right. So this would be the difference of two squares. So I'm going to do x minus 3 and x plus 3. Difference of two squares. All right, so this next one, this is the basic trinomial factoring. I'm looking for factors of 8 that are going to give me a 6. Factors of 8 that are going to give me a 6. And that would be 2 and 4. So I have x and x. I have 2. I have 4. They're both going to be negative. Remember that you have to follow the integer rules. Negative times negative is positive, and negative plus negative is negative. Okay. So what can you do when the a is not 1? So when I'm talking about the a, I'm talking about the coefficient of the x squared, because remember, this is standard form. So I'm talking about this, the x squared. When the a is not a 1, you're not going to get this nice xx. It's just not going to happen. So you have to think of some other things. There's basically 3 approaches that we take to this. One is guess and check, which is something you can always do because guess and check, if you're good at it, it works. Okay. Splitting the linear term, this is what I'm going to show you today. And the tabular method, that's like the area method that we did yesterday. But remember, you always want to start by seeing if there's a GCF, because perhaps the 6 in the front can be dealt with by just dividing everything by 6. And if that is the case, then the a does become a 1. But not everything there is divisible by 6, so I have to deal with the 6. Okay, so I'm going to start by saying no, there is no GCF, and then I'm going to multiply the a times the c. And the a times the c is going to give me a 36. It's actually a negative 36, and if you want to write the negative, you can. All right, so now I'm going to list the factors of 36, and that's 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now, when I'm looking at it, I'm trying to get a 5. So to get a 5, I'm going to use the 4 and the 9. Now, more precisely, I want to get a positive 5. So that would mean that the 4 is negative. Okay? And now what I'm going to do is I'm going to split. So I'm splitting this positive 5. It's called splitting the linear term. The 5x is the linear term. So that gives me 6x squared minus 4x plus 9x minus 6. Okay, now I'm going to factor, and you start by looking only at the first 2, and you find the GCF of the first 2, and that would be 2x. And that gives me 3x subtract 2. Now, the key here is that 3x subtract 2 is going to be used again. All right. And for me to get that, I'm going to have a positive 3 out here. Okay. And that's factoring. So what you're doing is you're looking at it as 2 individual pieces, the first binomial, the last binomial. And you're factoring out the GCF from both of those binomials. Sometimes the second term, you're going to pull out a negative number because that could happen. All right. So now I'm going to bring everything back together for my final answer. And I bring back together the 2x plus 3. And then I write the 3x minus 2. Because basically the 2x plus 3 was distributed to the 3x minus 2. And that's my answer. And this is called splitting the linear term. Okay. So here we go. All right, so the first thing I'm going to do is check for a GCF, and there is no GCF because the 2 is not a factor of the negative 1 here. So now I'm going to do a times c, so 2 times 10 or 2 times negative 10. So that gives me a 20. And again, if you want to write negative 20, you can. I'm going to write it this time. All right. So my factors of 20 are 1 and 20, 2 and 10, or 4 and 5. And I'm trying to get a negative 1, so I'm going to choose the 4 and the 5. To get the negative 1, the 5 has to be negative. So I'm going to split this. That gives me 2x squared plus 4x minus 5x minus 10. So now I'm going to work only with the front, and I'm going to pull out a 2x. And that leaves me with x plus 2. Now here's the key. This has to be x plus 2 because those always have to match. So that's why I'm pulling out a negative 5, which might not seem normal because we've never really pulled out a negative GCF before. So that can happen. It's more about the fact that the x plus 2 has to match the x plus 2 because this comes from the distributive property. Somebody distributed a 2x minus 5 to, or onto, I guess maybe onto an x plus 2. Okay, and this is called splitting the linear term. All right, so I'll do one more. Well, I'm going to do them all, but I'll do one more and then we can talk again. Okay, so I'm going to do 6 times negative 20. 6 times negative 20 is 120. And I'm trying to get a 7. Remember, you can always use your calculator and do 120 divided by x. All right, 1 and 120. I know these are too far away. 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20. I'm getting there. 7, no, 8 and 15. Ooh, 8 and 15, 8 and 15. I'm going to stop. Okay. So I have 6x squared minus 8x plus 15x minus 20. So I chose 8 and 15. The 8 is going to be negative because this has to be negative 120. And when I add them, I have to get a 7. Okay, so now I'm going to split the linear term. I did that already. So now I'm going to factor. So that's 2x times 3x minus 4. The 3x minus 4 has to be used again. So I believe this is plus 5. So the 2x plus 5 comes back together, and the 3x minus 4. Because at one point, that 2x plus 5 was distributed. So we did the 2x times the 3x minus 4. We did the 5 times the 3x minus 4 to get the product, which is the question. Because remember, factoring is it's almost like division. It's kind of like dividing blindly because you don't know what you're dividing by. All right, so if you could just stop the video and then try the next two. I'd say take like 5 or 6 minutes and then restart the video to check your 3 and 4. Okay. I'm going to keep going. I think the red shows up better, so I'm going to use the red. All right, 6 times 2 is 12, 1 and 12, 2 and 6, 3 and 4, winner, winner, everything's positive. So 6x squared plus 3x plus 4x plus 2. Pulling out the 3x gives me 2x plus 1. Repeats. 2x plus 1 repeats. This is plus 2. So I get 3x plus 2 times 2x plus 1. And obviously I can check it. Looking good. Okay, so 3 times 7 is 21. 1 and 21. 3 and 7. Winner, winner. So 3x squared plus 3x plus 7x plus 7, pulling out a 3x, x plus 1, repeats the x plus 1, and a 7. So 3x plus 7 times x plus 1. And that's it. That's called splitting the linear term. All right, so you guys are going to work on the more practice. If you have questions, you can always talk to each other. And I will post the answer key for the more practice for you. All right, have a great day. See you tomorrow.